Good afternoon, everybody. Thank you for coming to Alyssa Sargent's talk. How many of you have a hummingbird feeder hanging outside? Excellent. Oh my gosh, this is a bunch of hummingbird junkies if we've ever had them together. How many of you seen a hummingbird today? Okay, that's pretty good. Well, you're in for a treat. Alyssa Sargent came to University of Washington a couple of years after she got her bachelor's degree at Messiah College in Pennsylvania. And she spent a couple of years after graduating to go around the world and to do a whole lot of cool bird things. She went to Australia, she went to a number of bird stations and participated in interesting projects here and there. And then finally she decided it was time to settle down. So she joined our biology department PhD program, the department in which I've been active. And the department is very proud of her. And in 6 weeks or so, she will present her final dissertation. And you're going to hear a little of that today. Let's applaud already for that. I don't want to spend too much more time introducing her because you're going to learn all kinds of things about hummingbirds in general, and in particular about hummingbirds in Colombia at a field station where she's worked. I think I've said enough. Remember, we like to save our questions until the end. We've got plenty of time to engage Alyssa for as long as we can all stand your questions and answers afterwards. So save up your questions. I think we're about ready to begin. So Alyssa, come on up and we'll get your mic on and let you get started. Thanks for coming today.
Okay, can everybody hear me all right? Yeah? Okay, excellent. Hi, nice to meet you all. My name is Alyssa. Thank you, Jim, for that great introduction. So I'm going to be talking about my work studying hummingbirds. We're going to hear a lot about hummingbirds today, a lot about what I do, a lot about fun facts about hummingbirds, and yeah, happy to take whatever questions you have. So Jim has already kind of said some of this, and can you hear me all right, by the way? Yeah, perfect. Jim has already said a little bit about what I've done before, but just to give you a little bit of background about how I got to be where I am at now and all of the things that I've been doing to get here. Basically, when I was in my undergrad, I went to a small liberal arts college. I wasn't really clicking with any of the biology classes I was taking. Nothing really felt right to me. And it wasn't until my third year that I took an animal behavior course, and then I finally felt the thing that you're supposed to feel where you say, oh, I could see myself doing this for a whole career. I finally felt that. And so animal behavior is just such an interesting field of study, learning why do animals make the decisions that they make, why do they behave in the ways that they do. It's essentially animal psychology, and so it's so interesting. And so after I graduated, I was really interested in studying birds. Birds were a really big part of that animal behavior class, so I was really interested in learning why do birds specifically behave in the ways that they behave? And so after I finished my degree, I went to a number of different projects studying birds around the world. So Jim already mentioned I did some work in Australia. These are these two right-hand photos here. I did some work in the Azores, which are all of these three left-hand photos. And then I also did some work with owls in Canada. It was just a really fun time. It was a fairly nomadic lifestyle as well. So, you know, you're kind of just, you're living at one place for a few months at a time, and then you move and you do something else. And so most of the time I would fly to one location, and then I would maybe come home for a day, and then I would fly to the next, or I would fly straight to the next location. So it was pretty nomadic. It was really interesting. I mean, I got to meet a lot of really cool people, study really cool birds, see really cool things. But, you know, at the end of the day, I was kind of thinking to myself, okay, I do want to maybe settle down a little bit. I would like to study my own research and study the things that I want to pick. And so I was doing a lot of emailing to try to find somebody who could help me work with hummingbirds specifically. I had a little bit of experience working with hummingbirds at this point, but it was hard to find somebody who had the funding and the capacity for students, and the interest in hummingbird behavior. So it was a lot of me sending emails to people and people saying, sorry, I can't take on another student, or just people not answering at all. And so finally I found Rico Guevara, so he's my current supervisor at the University of Washington, and he's awesome. And he studies hummingbirds, and he focuses on all sorts of stuff, including behavior. So he was a really good option. And so I finally found him, and we ended up doing an interview. It went really well, and I decided to do grad school with him. And why hummingbirds specifically, we'll talk about basically for the rest of my talk. That's something that, yeah, we're gonna focus a lot on hummingbirds. It's gonna be all hummingbirds from here on out. So in my work, just to ground you, I do work in Colombia, specifically near Bogota, in sort of mid-elevation region. So this shot that you see, this is a drone shot of the landscape surrounding our field station. So this building with the red roof that's coming into focus, that is our field station. We're gonna pan down on it in a second. But my work, we do a lot of work here, so this is where we catch all of the birds that we work with, and this is where we do most of our processing, where we take their measurements, and we do all of the sort of experimental side of stuff. But my work also does extend into this landscape as well. So that's just a little bit of visual context for all of the places that we're gonna be talking about as we move on. Now, hummingbirds, again, why hummingbirds? I wanted to show you some other hummingbirds. I mean, if you've, I saw some hands up, people have had feeders. I think you have a feeder here as well at the Hearthstone. Okay, yeah, so you've probably seen the Anna's hummingbird, which is the most common one around here. But I wanted to show you some hummingbirds that looked maybe a little bit different from what you're used to if you haven't done some traveling down in South or Central America. And so we've got a lot of hummingbirds that have crazy crest feathers. Those are those feathers sticking up on the head, really long tail feathers. Also, in this case, we've got some really specialized bills. This is the sword-billed hummingbird, the only hummingbird that has a beak longer than its body. This is the sickle-bill hummingbird. We'll talk more about that species later, so I'll save some facts for that one as we go. But yeah, essentially hummingbirds are really varied beyond just the typical hummingbird that we're used to seeing here in the United States. So hummingbirds it's a family of about 366 species, just depends on, what scientists are doing and, if they're breaking species apart or not at a given moment. So yeah, hummingbirds are really diverse, and they're really extreme birds. And that is one of the reasons that they interest me so much. And so I wanted to do a little bit of a demonstration on how extreme hummingbirds are. And I thought, what is a better way to do that than by doing a little face-off between hummingbirds and arguably one of the most extreme humans alive today, Dwayne "The Rock" Johnson. So May has already seen this slide. She attended another talk of mine, so apologies, May. So we're gonna start by doing a little round of speed. Now, Usain Bolt, who is the fastest man in the universe and arguably the person that I should have put on this slide, but I did not, he tops out at around 27, 28 miles per hour. So he's very fast. Whereas hummingbirds, when they're flying just forward flight, so we're not talking dives or anything crazy, they can fly at around 31 miles per hour. That's how high they've been clocked to. So even at his absolute fastest, Dwayne "The Rock" Johnson is not gonna be faster than a hummingbird. And if we're talking about dives, hummingbirds can dive at around 61 miles per hour. So yeah, we're gonna give a point to our bird, and I have no doubt you can guess where this is going already, but we're gonna keep going. Okay, the next round is metabolism. Now, if Dwayne "The Rock" Johnson were to burn as much energy as a broad-billed hummingbird, which is this species that we've got on the slide right here, he would have to eat around 6,110 chicken nuggets in a day, which we can assume he's not doing on his biggest cheat day, right? Or he'd have to eat 193 12-inch pizzas. Again, we're gonna assume he's not doing that, so we're gonna give another point to our bird. Okay. Next up, acceleration. Now, hummingbirds can accelerate at around 10 G. So that's about comparable to what a fighter jet pilot would experience. So when they are accelerating at their utmost, it is very intense. And so to put it in another form, Usain Bolt, we're gonna go back to our example of Usain Bolt. When he's coming out of the starting blocks, he can accelerate between 8 to 10 meters per second, whereas a hummingbird can accelerate around 98 meters per second. So we're gonna say again, another point for our bird. Okay, now let's move on to movement. Now, scientists have estimated that when hummingbirds are migrating, they can migrate around 19.9 miles in a day. I think actually it's probably more, but we require some specific technology to actually get into that, and we'll talk more about that technology as we go. But 19.9 miles for a hummingbird that we would have here in North America, that's around 400,000 body lengths in just one day. So that's a lot of body lengths for a bird that tiny. Whereas for humans, this is the only number I have to look at on my slide because I don't remember this off the top of my head. The greatest distance covered by a human in 24 hours, this is a record that was broken a few years ago. I should check to see if it's been broken since. But this is a man who was able to run 198.6 miles in just 24 hours, which is absolutely insane, really impressive. But if we break it down into actual body lengths in a single day, that man was 5'11". So he was able to travel around 177,000 body lengths in a single day. So still incredibly impressive. And in absolute terms, he definitely would beat out the hummingbird. But if we're going by body lengths, the hummingbird is doing more than double what he's able to do. So I'm gonna give a point to our bird. We could give Dwayne a pity point, but I'm not going to. Okay, now round 5, reflexes. Now our fastest human movement, maybe you would think is blinking. It actually takes us around 150 milliseconds to blink, according to some scientists. I haven't run the calculations myself or timed it. But actually the fastest thing that we can do is snap our fingers. It takes, according to scientists, 7 milliseconds to snap your fingers. So really impressive. And a hummingbird can flap its wings up to 135 times in 1 second. And so if we break down the math, that actually equals 7 milliseconds per flap. So the same amount of time, but we can't snap 135 times in a second, right? We could, it takes a while to get your fingers in the position to generate all that friction. So we don't quite make it that fast. So I'm gonna give another point to our bird because they're able to sustain that. Oh, and then another fun fact for you is that it takes hummingbirds around 50 milliseconds to lick at nectar. Their tongue moves really fast. Okay, so I'm gonna give the last point to our bird, then I'm gonna crown our bird the winner. Better luck next time, Dwayne. Okay, so hummingbirds are clearly pretty well studied, right? There's a lot of facts we just heard about hummingbirds. There's a lot of interesting biomechanical work that's been done with them, a lot of energetics work. They're really good subject study for all of those things. But in terms of behavior, hummingbirds, there's actually a lot that we still don't know about them. And I want you to think about why that might be. And this slide might give you a pretty good clue, which is, if you take a look, this is a striped-throated hermit that we caught in Ecuador. This bird, as you can see, is about the size of my colleague's upper thumb knuckle. So if you take a look at your thumb knuckle, that's about how big that bird is. Very, very small. It weighs around, when we caught it, it weighed 2.17 grams, which is equivalent to about 2 M&Ms or a penny. So as you can see, they're very small. They're also, as we heard, very fast, right? So they're faster than Usain Bolt. They're faster than you or me or Dwayne "The Rock" Johnson. So those two things combined, plus you can't really see in the background super well, but This is a very dense cloud forest that we were working in. So the vegetation is really thick, it's really steep terrain, there's a lot of trees. So essentially, if you've ever seen a hummingbird at one of your feeders and they fly off really fast, and maybe you wonder where they went, in a cloud forest or one of these more complicated systems that hummingbirds can live in, it's even harder. So we've got a bird that is really tiny, really fast, lives in a complicated system that's difficult to navigate. It makes it really hard to know what a hummingbird is doing all day without technology. And so that's where the tech comes in, which is what I focus on with my work. And we'll talk more about that soon, not quite yet. Now, one of the things that we're really interested in with hummingbirds is how they deal with competition. As you can see, there's a lot of competition happening here at this feeder. This is one of our feeders down in Colombia, and there's quite a few of them, as you can see, and quite a few species as well. So if you've ever traveled to South America or Central America, or even maybe California or some places like Arizona where there are a lot of hummingbirds, and the numbers can get really thick and fast, in that case, you might see feeders like this, but here, of course, in Seattle, that's not very common. But this is pretty common where we work, that there are just tons of hummingbirds, and they're all competing for resources together. And so how are hummingbirds navigating all of these other birds that are trying to get at the same resource as them? And so that's where strategy comes in, and we're gonna define strategy today as the tactics employed by species in adapting to different conditions. And that is mostly what I focus on in my work. What are the strategies hummingbirds have for dealing with competition and foraging and all of those things? So I'm gonna return to our Ecuador site. This is a very stylized image of a drone image overhead with, I added all of these little plants in here. They don't look like that in real life exactly. But this is a very stylized image of what our site looked like in Ecuador. So as I mentioned, it's a really complicated system, a lot of trees. But another thing to keep in mind is that flowers have their own strategies. So not only are hummingbirds having their own strategies for dealing with competition, but plants have their own reproductive strategies. So some of them, like this heliconia, this lobster claw style plant, are spread really far across the landscape. And then we have others that grow in these really thick clumps, like this Caliandra and Elianthus. So there are just different ways that plants are growing as well. So that's also worth keeping in mind. So the hummingbird's dilemma thus becomes, should I stay? So should I be staying at these clumps of flowers? Should I be visiting these flowers that are really spaced far apart? Or should I do something in between, some other strategy beyond those two? Now, the birds that stay, we consider these birds to be territorialists. And we'll talk about territoriality in a second. The sparkling violet ear is a really good example of this. They're a bird that fits all of the criteria I'm about to talk about. So this is a species that we would get down in Latin America. Specifically, we have them at my field site. Okay, so this is a bird. A territorialist is a bird that will defend resources. So this is kind of the behavior that if you have a feeder here, you've probably seen. They'll chase other birds away. They want to monopolize that resource. They are also birds that tend to have larger body sizes for combat. So it's kind of like any organism, including humans. If you have a physical advantage over, if you're bigger than your opponent, you tend to have an advantage in combat over the person that you're fighting against. Okay, we also tend to see generalized and weaponized bills with these birds. Now, generalized meaning it's not a super long or curved beak, which we'll see what that looks like soon with the sparkling violet ear. But these are birds that tend to not be super co-evolved with certain flowers. They tend to be more generalized in what they feed on. And weaponized bills are essentially bills that are really serrated or dagger-like at the tip, which they use to attack one another. We'll see that soon. And then these birds also tend to have brighter colors, like this violet ear you can see, which they use to display to one another, either to rivals or for mating purposes. Okay, now, this is what combat tends to look like with hummingbirds, it's usually really quick. So this is an indigo-capped hummingbird coming into frame. A rufous-tailed hummingbird is about to attack him. Yeah. So this is very slowed down. We were filming at around 1,600 frames per second. So this is happening really quickly. And if you have a feeder, this is what's happening all the time between hummingbirds. It's just that it happens so quickly, it's like almost impossible to see it visually with just, the naked eye. So this is what's happening kind of constantly with hummingbirds. And as you can see, this bird is coming in and kind of using its bill to stab at the other hummingbird. It's kind of like if you had a sword taped to the end of your face. That's essentially what they've got. And then with these serrations, this is a really extreme example. So this is a tooth-billed hummingbird. And as you can see, these serrations are really intense. A lot of hummingbirds will have serrations like this, but not nearly this pronounced. But the theory is that they are used to pull out feathers from opponents. So not only are they stabbing, which some birds have really, really sharp dagger-like tips, unlike this guy who's got a weird, curved tip here. So sometimes they have these dagger-like tips, and sometimes they have these serrations, which they're using to yank out feathers. Now, how do we actually study this staying behavior? That's an open question, and that's where the technology comes in that I was talking about. So one form of technology that we use is what we call radio frequency identification technology. This is, in this case, it's a specialized antenna that we've got here. And so it will pick up any microchipped hummingbirds. So we'll microchip our hummingbirds. Like if you have microchipped a pet in the past, you'll be familiar with this. It's the same technology. It's also the same, as what's in your credit card. When you tap your credit card at a reader, it's the same tech. And if I don't actually know what it's called here. On the East Coast, we call it Easy Pass, but it's the thing that you use to go through a toll automatically. It's the same technology there as well, the little thing that you put on your car. So radio frequency identification technology is really ubiquitous, and we're able to use it to, essentially, we put these specialized antennas on our feeders, and then we see which hummingbirds that have microchips are visiting and when and what time, and you can pull apart a lot of really interesting data from that. I wanna show, this is what it looks like in action. So you can see it's lighting up. This bird that's visiting here, he's got a microchip. So you can see that it's recognizing that he's there. So with this tech, like I said, we can pull apart a lot of interesting data. This is an example of some maps that my colleague put together. So he was using RFID technology in Panama in one of his field sites. So I'm gonna break down what's happening here. All of these gray dots, these are feeders that have an RFID antenna on them. Oh, radio frequency identification technology is shortened to RFID. Sorry, there's lots of lingo that I have to remember. Okay, so this, all of these dots are feeders that have these specialized antennas on them. And then you can see these trails are obviously connecting different hummingbird visits to these feeders. And so each name up here is a different type of hummingbird, and the color represents the time of day that the bird was making these visits. And these numbers, which you might not be able to see, they're really small, so I'll walk you through what the numbers are, indicate how many times a bird visited those feeders in a day. So essentially, on the very, very left here, we have Era's bell. We can essentially pull apart what birds are doing and how the strategies look different. So on the left hand, we've got Era's bell, and you might not be able to see it, but that bird visited one feeder 138 times and then one other feeder once. So that's one example of what we would consider to be probably a pretty territorial bird. And we've got other examples like Joseph, who's here in the C panel and in the F panel with some different strategies. So we could have birds like Joseph that's visiting lots of feeders all over the place, really crazy pattern. And then in this other day, a little bit later, about a month later, he visited one feeder 49 times and then two other feeders 3 times. So he's got a really sort of crazy strategy in the beginning, and then maybe he focuses down, and maybe that depends on the competition that he's facing. We have other examples of birds like Dahlia. This bird visited 24 times to this one feeder and then 21 times to another. And then Abelardo on the very left in panel D there, he visited one feeder 3 times. So that highlights a limitation of this technology, which is if a bird isn't visiting your feeders, you don't know what it's doing. Like this bird was probably visiting lots of flowers as well. Or even maybe feeders that other people had put up in Panama that just didn't have an antenna on them. So that's one limitation. We don't know what a bird is doing when it's not visiting the feeder, but it still does highlight, we've got some really interesting data here nonetheless. Okay, now I want to move on to an experiment that I did with this same sort of technology in Colombia in our field site. So our field site has around 15 to 20 feeders that are stocked every day, year in and year out at that field station. So we replace the sugar water in them every day. So the hummingbirds are very used to our field site. So in this experiment, I'm gonna walk through what we did. We had 16 feeders that we had kept up for a good amount of time to get the birds used to them. And as the experiment went on, we removed feeders. So we went down to 12, and then 8, and then 4, and then we went back up to 8, 12, and then eventually 16 feeders. So we were working with a lot of species. So at our field site, again, we had around 10 species that we had microchipped that were visiting the feeders. And that broke down into, during our experiment, which was a 3-week experiment, we had 109 birds visiting. So there were a lot of birds. And basically this graph, what we're looking at, we've got average visits per feeder per day on the y-axis. And you can see that as you remove feeders, the competition really does spike. You get tons of visits to the feeders that are left, what we call the core feeders. And so, as you can see, as you return the feeders, the competition goes back to sort of what it was before. Actually, it depresses a little bit. The birds were a little less trustworthy of our feeders after that, which makes sense. Okay, now another way to look at what we were doing is an access metric. So these are pretty new. I just put this together like last month. So you're seeing stuff hot off the presses. So essentially what I did was I created an access metric. So I looked at the first period of 16 feeders, and I looked to see if I split the birds into 3 tertiles of, okay, here are birds that were visiting a lot. Here are our top access birds. And then I looked at the birds that were visiting just a moderate amount, and those were our mid access birds. And then we had our bottom birds that just didn't really get much access to the feeders. They were visiting a little bit. And I looked to see, as we removed feeders, how do these birds of these different groups respond? And so on the y-axis here, we've got the percent of individuals present each day. And so essentially, as you start removing feeders and the competition gets really steep, the birds that didn't have much access to begin with lose more access, and they basically get completely just cut out of the system, more or less. So this graph only does go down to 25% at the y-axis. So it's not like every single bird that didn't have much access to start got completely cut out, but the vast majority do when the competition is really steep. And then it does go back up as we go on throughout the experiment again when we start reinstating feeders, but it just doesn't really completely ever go back to normal for any of the groups. And then the birds that were high access to start maintained their access, more or less. So basically, scarcity is not equal amongst all the birds. Okay, now the same thing, we're looking at the exact same thing, but now we're breaking it down by species, okay? So I'm not breaking it down by access group. So for instance, let's pull apart a couple of species. We've got the black-throated mango, that's this pink line here. They are really beautiful birds, really pink tail. They are pretty territorial, pretty dominant. They did pretty well throughout the experiment until we get down to 8 feeders, and they suffered a lot. A lot of birds dropped out. And then when we went back to 12 feeders, they came back pretty well. And then for another example, we've got our brown violet ear. So this, you can see the line looks extremely straight here. It's because when we started the experiment, there were 6. And then by the end of the experiment, there were only 5. So the one bird dropped out once we went to 12 feeders and didn't come back. And that was it. So that's why the lines look a little bit different for this species. And then we have other birds like, this is the white-vented plumelet, this dark green line. They just kind of didn't do very well as we went on. They just lost a lot of access to the feeders, essentially. They kind of got boxed out when competition got pretty steep. And they're just not birds that are very dominant. They also tend to be a species that we've seen some pox with them, some avian pox. So some of them are sick. So maybe they just aren't able to handle the increased competition very well. Okay. Now, this is another couple of plots just to show a couple of more things that you can figure out with this sort of technology. So again, we've got our species that we're looking at here. And on the y-axis for this top plot, we've got average daily visits. So we can see that some species had a lot of visits every day and some species just not quite as many. So the brown violet ear, we've got a lot of visits here when we've got 12 feeders, so around 100 visits on average for one of those days. And then as we start to remove feeders, they just sort of middle out and join with the rest of the species. But the brown violet ear, we talked about the sparkling violet ear, very aggressive, very combative, and they've got that weaponized bill tip. They're similar. The brown violet ear is related, and they're extremely aggressive, maybe more so even than the sparkling violet ear. So they tend to maintain pretty good access. And then again, we've got this white-vented plumelet ear, the ones that just, they're not very good at maintaining a grip on feeders. So you can see that they just don't have very many visits kind of throughout the experiment, less than every other species. And then here on this bottom plot, we've got feeder loyalty, which is just a metric that is looking at the percent of visits to a bird's favorite feeder. So basically, how much are they spreading out their visits across feeders? Are they doing that, or are they just visiting one feeder all the time? And so we can see that the brown violet ear is really visiting feeders that it likes a lot. And you can see when we get down to 4 feeders, peak scarcity, that bird is visiting its favorite feeder. Those birds are visiting their favorite feeders every single visit almost. So they're really, as I said, really dominant, really aggressive. So they manage to just maintain access at one feeder, and that works for them. And we have other species like, for instance, this is the indigo-capped hummingbird. This is the species that we saw getting attacked by the rufous-tailed in that flyby shot. You can see that as the experiment goes on, they also end up visiting their favorite feeders less, so they tend to spread out their visits to different feeders more. Okay. Now, I'm going to shift gears. We're going to talk about the birds that go. This is what we call trap lining is the term. Also, I see I've been talking a lot, so sorry. I'm going to go kind of fast through, I think, most of the rest of this presentation. I didn't realize I've been talking quite so long. So the birds that go, trapliners, these are birds that tend to visit flowers in a sequence, and they move long distances. So that is a term that's inspired by the concept of fur trappers. So fur trappers have a line of traps that they'll visit. They'll check each trap, and they'll do that in a circuit. And the white-tipped sicklebill is a really good example of this. So these birds don't tend to defend resources. They're not territorial. The white-tipped sicklebill is quite elusive. They're very shy. They also usually have smaller body sizes so they can commute better. It's kind of like a marathon runner versus a sprinter with a really big build. So these guys tend to be smaller, although the white-tipped sicklebill is an exception. They are quite big, but most of its relatives are not. They also tend to have specialized bills. So this species, you can see, he's got a really, really curved bill, super co-evolved with certain flowers. And this lets this bird access flowers better than other species. Certain flowers, this bird just can't really visit because of the shape of its bill. And then these birds also tend to have duller colors. They tend to camouflage a lot. Okay, now how do we study this going behavior? We use a lot of different types of technology. So these two devices we see here are radio tracking devices. This on the left is an accelerometer, and we'll talk about that in a second. But for now, we're gonna focus on radio tracking devices. So these are devices that will put out a radio signal, and we will pick it up with different antennas that will spread across the landscape. So essentially the system works by, you have multiple antennas, they're picking up the radio signal, and based on the strength of that signal at all these antennas, you can pinpoint where the bird is, or you can triangulate its position, essentially. So this lets us create maps. And this looks really complicated and messy. This is 20 birds that we were tracking, 20 black-throated mangoes, so all the same species, and this was over the course of around 2 weeks. So you can see there's a lot of movement happening, and let's break it down a little bit easier to visually parse. This is an animation of their movement over the course of the day, just one of the days, and this is sped up, so 1 second is 1 hour in this animation. They don't move quite that fast in real life, but you can see that there's some different strategies happening here in the movement as well. So like on the bottom here, we've got this bird, this red line that's moving just kind of in one location. It's not moving a crazy amount. And then we have, for instance, this yellow line for this bird that's going all over the place. So in terms of movement too, really different, really varied. And this is really complementary technology with the radio frequency identification technology I was telling you about, which is if a bird's not at the feeder, we don't know where it is, whereas this lets us see what the bird is doing. We just don't know exactly, what resources it's visiting or any of those really specific details. Okay, now this is an example of the accelerometer data that you can create. So essentially we're looking at acceleration on 3 axes, X, Y, and Z, and I'm gonna talk about this pretty briefly. But essentially what you can do is you can pull apart based on when there's no acceleration happening, a bird is perching, versus when there's lots of acceleration happening on these axes, a bird is flying. And you can even break this down further so you can look at when a bird is preening or when it is feeding, for instance. So maybe hover feeding versus flying or versus perching. So all of these things let us break down even further what a bird is doing, because we've got this sort of like broad information with the movement, right? We can see, okay, they're moving all over the place, or they're kind of hanging out in one location, but this lets us break it down in more specifics over a shorter period of time. Okay, research sneak peek. So this is actually stuff I've already done. We just haven't analyzed the data yet. So I talked about how those two forms of technology, radio tracking and radio frequency identification, those are complementary. So during my experiment, when we were manipulating how many feeders there were available, I actually was also radio tracking a subset of those microchipped hummingbirds. So we can essentially see, okay, of these birds that were visiting during the experiment, how many of them were moving in different ways and where were they moving to? And if a bird wasn't at the feeders, was it still hanging around the feeders, or was it just somewhere else completely? Okay. This is another type of tech that you can use. I'm not going to spend much time on this. This is called a wind tunnel, which is essentially a chamber that you can put a bird in, and you can crank up the speed on these really, really big fans, and you can see how the bird can withstand this wind. So you can essentially figure out how fast it can fly. So that's one way to figure out top speeds of birds, for instance. So this is a species that's related to that white-tip sicklebill that we were talking about. And you can figure out a lot of cool stuff like kinematics of how they flap their wings, biomechanics, the energetics of how they're doing all of this, but that's for another day to talk about. Okay, and then lastly, I'm gonna just talk about for the strategies. I'm going to talk about birds that have the in-between or a different strategy. These are birds that we call filchers. So they're little thieves. And the magenta-throated woodstar is a good example of that. So these birds tend to have short, generalized bills. They're not super specialized. They also tend to have smaller body sizes for sneaking, and sneaking comes into play in what they do, which is called territory parasitism. So they essentially will go visit a territory that is quote unquote owned by another hummingbird. They will sneak in and try to get some nectar, and then they'll sneak out. And they'll just keep doing that. So they'll try to do it when there's not much competition, or maybe the hummingbird's not paying attention to them. And so that is their way of, they don't have to do the really long distance specialized flower thing, but also at the same time, they don't have to do all of the combat that's associated with maintaining a territory. So they're just very sneaky. And they also tend to have brighter colors for display. And I was gonna show a video, but I forgot to log into the Wi-Fi, and honestly, it's like a 3-second video anyway. It's just this is an example of a filcher. He's just a very shy bird. He'll come and visit the feeder, and he'll hang out, and then as soon as another bird shows up, he'll fly away. Okay, now, here we go. Now, this is the last thing I want to talk about, which is Hummingbird Sugar Rush, which is a board game that I developed to teach people about these different strategies that we just talked about. And so in the game, you can play as one of the 3 species that we just focused on. And your goal is to collect as much nectar from flowers as you can while also fighting off other hummingbirds. So this is just, an example of, or a little progression of how we got to put this game together and bring it to life. And now we have a Spanish version, which is really fun. And yeah, in the game, like I said, you play as one of these 3 species. There are different territories. So for instance, if you're a sparkling violet ear, you're very good at combat, but you can't leave your territory because you have to keep monopolizing those resources essentially. Whereas if you're a white-tipped sicklebill, you're really bad at fighting, but you can move long distances, and you can also feed from flowers that other birds can't. And if you're a filcher, you're just able to move in ways that other birds can't move on the board because you're very versatile and able to, move quite quickly. Okay, so we've also played this game in what we lovingly call the chaos version, which is where the kids play as the birds themselves, and they have little stomachs for all the nectar that they collect from the flowers. And combat is just rock, paper, scissors. So it's pretty simple. Not quite as cutthroat as real life. But yeah, so I guess that about wraps us up. I guess I would just say that if I want you to take anything away from this talk, it's just that hummingbirds have really complicated behavior, and there's a lot we still have to pull apart from it. And hummingbirds don't all behave in the same way, and there are lots of strategies that they use to mitigate competition or avoid it or dominate it. And so I will be happy to take any questions you might have, whether or not you want to ask them now or email or whatever. Yeah.
Thank you.
Thank you. Thank you.
We've got plenty of time for questions, and I can come with the microphone if somebody would like to speak a question or
I
shout
see
it
some
out
hands
otherwise.
up.
Jen, want me to shout? How do you get those chips on the bird? I mean, they're very light to begin with.
Yeah. The question was, how do you get the chips on the bird? They're very light to begin with. Are you talking about the microchips or the little tracking devices?
Either one. I mean,
Yeah, either one. Great question. So the microchips are like if you microchipped your pet, it's an injection. So it's a subcutaneous is what we call it. So it's very, very tiny, and you just inject it between the scapulae. Whereas these sorts of tags, we will attach them a number of ways. So we've used harnesses, it's like what we call a backpack harness. So essentially it goes over and under the wings, and then the tag sits on the back. Or we will glue them. So we will use we usually actually use a wig glue that people will use in, for instance, Hollywood to attach wigs to their heads. So it's, safe for skin. and the tag will just fall off eventually if we don't manage to catch the bird before it does. Yeah. Does that answer your question, or do you have a follow-up? Okay. Yeah, they're very tiny. It takes a lot of specialized training to handle and work with hummingbirds. Absolutely, yeah.
Why do all hummingbird feeders seem to be red?
Good question. It's because hummingbirds tend to visit red flowers the most. So hummingbirds tend to visit red flowers the most because they tend to have the most nectar, and they tend to be bigger flowers. So that's actually why. I think there's a prevailing understanding that hummingbirds can see red better. And I was just reading a paper about hummingbird vision the other day, and hummingbirds actually have better vision than I do with my glasses. And it's actually because, red flowers tend to just have more nectar in them. So they tend to like red flowers. So people have based feeders on that. So that's why. But you can have a feeder that's any color, and they will probably visit it if they're curious enough. They'll visit flowers of any color.
If they have to eat so often, how much time do they have to sleep?
Yeah, that's a good question. Hummingbirds have different methods to sort of manage that, the fact that they burn so much energy and they have to eat a lot. But the hummingbirds that I work with down in Colombia, they'll go to bed right at sunset and they get up right at sunrise. So they'll sleep, it's about 12 hours, yeah. So they sleep quite a bit, and in order to avoid just starving to death overnight, which is a concern because their metabolism is so intense, they will do a couple of things. So they feed a lot at night right before they go to bed, and they feed a lot in the morning as well. So they'll essentially load up on energy and try to store it before they sleep. But then also beyond that, they can enter something called torpor, which is essentially a mini hibernation, and they can conserve energy that way. And they can just do that at night. Yeah.
What is the lifespan of a hummingbird?
Good question. If you Google it, I think Google will probably tell you about 8 or 9 years, but I've definitely heard of hummingbirds that live longer than that. We have records in the States of hummingbirds that are as old as 14 years and 4 months. So they can live a while, but also that's a minimum estimate because you have to catch a hummingbird once and then tag it or band it. Banding is like when you put a little anklet on a hummingbird and it's got a specific number on it, like a license plate, or some other form of tag. So you have to catch it once, tag it in some way, and then you have to catch it again. So the bird was alive before and after that. So 14 years and 4 months is the oldest I've heard, but that's a minimum. Yeah.
Do the hummingbirds here migrate, or where do they go in the winter?
That's a great question. Some of them do. So the Anna's hummingbird, it's a mix. So the Anna's hummingbird is the one you'll probably see the most around here. That's the males have the bright pink heads. They're really beautiful. Some of them overwinter here, so some of them just stay here all year, and that's actually due to people having put up feeders. The hummingbirds have gotten used to it, and they've extended their range northward, and now they just hang out here. But some do migrate down south. And then the rufous hummingbird, which will also get passed through here, they will migrate as far up as Alaska, and then they'll go back down to, I think, Central America. So yeah, they will migrate quite a bit. Good question. Sorry? When is the mating season for a hummingbird? Well, the hummingbirds here, it's very long. The mating season is almost the whole year. I think that I read that they start back up in December, and then maybe they end in like October or something. It's almost the whole year. And I wouldn't be surprised if it is the whole year. And just, people haven't found them nesting a whole lot in, November or something. Good question, yeah. What's the body temperature of a hummingbird? I'm going to be completely honest. I don't know the answer to that. I've never studied that. I definitely know a lot of people who study hummingbird body temperature. There are some people who study specifically torpor, that behavior that I mentioned, where they can lower their metabolism at night, and they'll study how much they lower their temperature. But yeah, off the top of my head, unfortunately, I do not know the answer to that. I'm sorry.
How many clutches do they have?
How many clutches do they have in like a single season?
Yeah, well, yeah.
That's a good question. It can be multiple for sure. I mean, again, like I said, Anna's hummingbirds kind of are nesting all year, so I imagine it must be a lot. But generally speaking, they'll take a little break after they will, successfully fledge a nest. But if a hummingbird's nest fails, they'll keep trying. So this is not specific to hummingbirds, but for instance, I studied fairy wrens out in Australia, and I had one bird that had 8 nesting attempts in the course of like a couple of weeks because they kept failing. So like they'll just keep trying and trying until they manage to succeed. Yeah, good question.
I heard that the females have longer bills. Is that true of all hummingbirds?
No, that's not true of all hummingbirds. So yeah, it's kind of varied. Sometimes the males have longer, sometimes they have different amounts of curvature to their bill as well. But yeah, it just depends on the species and how they're kind of navigating like niches and basically how they're able to, avoid competing so closely on the same resources. Good question.
Is there a ratio, sugar to water, to keep them coming? I haven't seen my hummingbird all spring now, the flowers are out.
Oh yeah, okay, the question
She's
was.
asking about the recipe for the feeders.
Yeah, is there a specific ratio for water to sugar? So it should be 4 parts water and 1 part sugar, I believe. So I believe it should be 20% sugar, essentially. But yeah, I mean, sometimes hummingbirds are just a little fickle. Yeah, I think just keep at it. I tell my mom that all the time because every season she's like, the hummingbirds are not at my house. I say, just wait, they'll come back. But you said you haven't seen them in.
I haven't seen them the feeder is there and it's not going down. So
Yeah.
and I haven't seen them.
Okay, yeah.
All winter.
Yeah.
Hung out there.
Huh. Yeah, I don't know. I mean,
Better choices.
maybe. I don't know. I think just, maybe they just found some other options. But I think give it some time, they'll show up. Yeah.
I don't need a microphone, I don't think. So what's the deal with the iridescent? I mean, it's amazing, the color. And so I imagine that's South America stuff, and we don't get to see that in the United States at all?
Oh, no, not at all. Okay, so the question is, do we get to see, is iridescence specific to Latin America? And no, the Anna's hummingbirds, the males have amazing iridescence. I can see if I can pull up a video, actually. Why not? Oh, you know what? Actually, I don't think it's going to work because I forgot. I'm not on your... Do you have the Wi-Fi password? I can try to log in. No? Okay. All right. Well, this video shows an Anna's hummingbird, and you can see in the video, I mean, obviously I can't show you right now, but he's turning his head, and it goes from looking black to looking pink, depending on the angle. So iridescence is really cool. It's essentially what we call structural coloration. So it's not pigmentation. So for instance, if you're looking at your shirt and you're changing the angle of it, there might be some shadowing, but the color stays the same, right? But whereas with iridescence, the actual color itself is changing depending on the angle. And that's because of light essentially bouncing off of certain structures within the feathers. It's really cool. Yeah, good question.
I am sure that Alyssa is not going to run away quickly after this is over, but maybe this is a time to stop and thank her again, and then she'll hang around. And if some of you want to come up and chat, she'll be glad to answer some more questions. So thank you very much, Alyssa.
Thank you.